Hello and welcome to this lesson about solving two-step equations, where the learning target for this video is solving two-step linear equations. So first of all, I want to talk about the process. A lot of it boils down to two words. Let me write that down. Two words. And those two words are isolate and balance. To me, that is the mantra needed for solving equations. I guess I didn't need to put a number there. All right, so yeah, the two words isolate and balance. What we're going to try to do is isolate the variable, which means get x by itself. Isolate the variable, and it could be, or n, a, whatever the variable is you're using. And then balance means that whatever you do to one side, you have to do to the other side, or work on both sides. Cool. Now, let's talk about something else that we have to do. And the second thing is work outside in. Okay? And when we go through some examples, I think you'll see what that means. But we're going to want to work outside in as we work on isolating and balancing. So now let's take a look at some examples. For our first example, let's say we have 2x minus 9 is equal to 13. Okay, so keep in mind we want to isolate and balance. So my goal is to get that x all by itself. That's what I mean by isolating. And what I'm going to do is work, again, outside in. Meaning I'm going to look at the other numbers that are around the x. I have a 2 and I have negative 9. Which one is further, quote unquote, outside? Well, the outside one is going to be the 9, and then the in one is going to be the 2. And so what I'm going to do is use inverse operations to take care of the 9 first, and then I'm going to take care of the 2. And so something I recommend students do is making what I call a mirror line, where we're going to mirror what we do on both sides. So I need to undo positive 9, or sorry, negative 9, which I will do by adding 9 to both sides. So add 9 to both sides, and now these 9s cancel each other out. So I have 2x is equal to 22. Now I'm going to continue to solve x, get x by itself, have my mirror line, and I'm going to divide by 2. And dividing by 2 gets rid of the x's on the left, and now I'm left with just x equals 11. Now, I want to highlight something here. This right here, this right here, this is what we call inverse operations. And this is, oh, that's not how you spell operations, is it? There we go. That is doing the opposite of something. So notice how we have a negative 9 here, and then I'm adding 9 to undo it. I'm multiplying by 2, I then divide by 2 to undo it. So let's walk through a couple more examples and see if we pick up on this. So second example, let's say I have x over 3 plus 5 is equal to 8. All right. So what I'm going to do now is continue to work outside and in, and I'm going to isolate and balance. And so first I'm going to look on the outside. What's the thing that's happening further away? And that would be my 5. So I have to ask myself, how do I undo positive 5? Well, I subtract. And if I have a mirror line going on, I have to balance out the equation and do the same thing over here. So the mirror line really helps you balancing things out. Now I have x over 3 equals 3. Now here's where you need to be careful. Some people are going to see this and maybe think the answer is 1, but that's not the case. I'm going to have to ask myself, what's actually happening here to x? And my x is being divided by 3. So if I want to undo that, I'm going to multiply both sides by 3. These 3's cancel each other out, and I get x by itself. So again, that's the goal, which is why I love to talk about isolating the variable. And now it equals 9. And there we go. We can box it and walk away. Now, let's take a look at some tricky examples. So for this one, I'm going to throw in a fraction. 2/3 x plus 8 is equal to 14. Okay, now what's tricky is that this is a fraction. Doesn't change anything, it simply changes what it looks like. My goal is still going to be the same. Get x all by itself and work outside in. So I need to get rid of the 8 because that's further away. I'll use the inverse operation of minusing 8 from both sides. Now I have 2/3 x is equal to 6. And here you might argue, hey, this is a 3-step equation, not a 2-step equation. But we can still get rid of this fraction if we times both the sides by the reciprocal. So here we'll times this side by 3/2, and we'll times this side by 3/2. And again, the reason why we're doing that is the reciprocal of 3/2. Reciprocal cancels out the fractions. So we only are left with 1 on the left-hand side. So all of that reduces down to 1, which just becomes x, equals, and then here we can reduce a little bit, 9. So the answer to this one is also x equals 9. Now I want to show you yet another tricky example. 4x plus 11 equals 11. Now we're going to play around with this equation because there's many different variations of it that you might end up seeing, and nothing really changes. It just looks a little bit tricky, and that throws students off. So still going to work on isolating and balancing. We're going to work outside in, so we want to get x all by itself. And the first thing I'm going to address is the 11, so I'm going to subtract 11 from both sides. Now when I do this, I end up getting 4x is equal to 0. I canceled out the 11s. It's totally fine. That doesn't change anything. Now I'll divide both sides by 4 because I want to get, again, x by itself. So I divide both sides by 4. 4's cancel out, and I have x equals 0 divided by 4, which is just 0. Some people freak out and think that 0 can't be an answer. 0 is any other number, and so it is a possible solution. All right, now that's one look of this. But now let me rewrite it just a little bit. What if we had 4x minus 11 equals negative 11? Or actually, better yet, wait, let me change that. Plus 11, or positive 11. All right, now here's what's going to happen. A lot of students are going to see this with their eyes, and they're going to think 0. That's what happens a lot. You see negative 11, positive 11, and the numbers can change. It might be minus 7, positive 7, whatever. You're going to think, oh, hey, those cancel each other out. But I have to encourage you, take your time. Actually perform the inverse operation. And show your work. This is where showing your work really comes in handy, because when you add 11 to both sides, all of a sudden you realize, oh, 4x equals 22. Not 4x equals 0. All right, and then you can end up dividing, not subtracting, dividing by 4, divide by 4. And here, x ends up equaling 22 over 4, which is the same as 11 over 2. Sometimes the answer might be a fraction. That's totally fine as well. The final variation I want to show you is what if we had 4x minus 11 equals 0. Again, it looks weird. Some students freak out about it, but this is no different than any other problem we've done. Same idea. Add 11 to both sides, add 11 to both sides, or add 11 to both sides to the left and the right. 4x equals 11, divide by 4, and you're done. So even though there's a 0, that doesn't change anything. Again, 0 is any other number. So that's how you solve two-step linear equations. Let me know if you have any questions on your homework or practice, and good luck.